Alright, calculus students, welcome to one of our technology, engineering, and education labs here at Summers High School. Those of you that have taken technology or engineering classes before, welcome back. Those of you that this is your first time, welcome. What we're going to be doing today is taking a look at revolving about an axis in one of our programs that we have here. What we'll be able to do is take a look at some of the formulas that you guys have been deriving or creating and implement them in one of our programs, revolve it about an axis, and verify the volume that you've calculated. We can go ahead and verify that volume within this program. So the first thing we're going to want to do is take a look at the bottom of your screen here. You're going to want to click on the SW button, which is Solidworks. This is the program that we're going to be utilizing. Solidworks is a globally recognized program in the engineering field that is utilized for creating technical drawings, but it goes far beyond that. It's also an engineering tool to utilize and evaluate materials to determine whether or not their strength is sufficient for an appropriate design. And as you'll see today, we can go ahead and verify many of your calculus functions or calculus formulas directly within this program. So it's a very, very vast and very, very deep program. Alright, so first thing I'm going to do is go ahead and just maximize this to take up my whole screen resolution. And you'll notice when SolidWorks opens, right now it's just a blank screen. So what I'm going to do to go ahead and maximize my screen once again is I'm going to auto show this or check this little pin, and when I click off, I should be able to hide this sidebar. So it's nice to hide this sidebar because it gives me more room to work. We're going to say File, New, and we're going to be creating a new part today. So within this program we could create parts, assemblies, and drawings. We're going to be utilizing just a single part. So I'll click on my part and I will say OK. Now when this opens a new part, you're going to notice a few things that you should be familiar with at this point. At the bottom left down here, you're going to notice that we have our axes. You're going to have X, Y, and Z. Alright, and we can rotate those axes by depressing the center button on our mouse, the little gray ball. If we hold that down and move our mouse, you'll notice that I'm able to move those axes right down here. You'll see my X, my Y, and my Z. What you'll also notice is I have three planes on the left hand side here that when I brush my mouse over them, they highlight and they show those planes. If I right click on one of these planes, I can actually click on Show with the little glasses here, and it'll keep that plane visible. I'm not saying that you need to do this, but it really just kind of shows you the planes that we have to work on. Alright, so this kind of gives us our quadrants. If you look directly at it, you'll see our quadrants here, our four quadrants, but it gives it in all directions, so we have this three-dimensional space here. Okay, I'm going to check these off so they're not shown. I'm going to hide all my planes. Another tool that you'll find to be extremely useful for what you're going to be working on today is if we go up to our View option and we go down to Origins. So I'm going to hit View, Origins. That's going to give me my exact origin that I can draw about. Now to take that one step further, if I say View, Grid, that will turn on a grid for me, or it should anyway, turn on a grid that we could utilize to see our individual quadrants. Alright, the next step that I'm going to do is I'm going to create a line and show you how to spin about an axis. What you guys will be doing is entering your formulas and revolving your formulas and then calculating the formula. So I'll show you real simply how we can go ahead and revolve and obtain the volume of an object, and then I'll show you where you could be entering your formulas. So if I come up to my Sketch tab, you'll notice up top here I have Features, Sketch, Weldments, Evaluate, Dim Expert, so on and so forth. If I click on my Sketch tab, what I'm going to do is I'm going to select a plane that I want to sketch on. In this particular case, I'm going to select my front plane, and I'm going to say sketch, that I want to sketch on my front plane. You'll notice my grid pops in, which is extremely helpful, as I was talking about. And about your origin here are your quadrants. Alright, so I think they go 1, 2, 3, and 4. Our quadrants moving in this direction. I'm going to be working up in our first quadrant for this particular case. So what I'll do is I'm going to grab just a simple line tool. And my line tool, all I'm going to do is create an axis of revolution at this point. Okay, so in my particular case, I drew a line that was about 2.86 inches. I'm just drawing a rough line. And then what I'm going to do is I'm going to take my spline tool. Now you guys are going to be using the equation driven curve, where if I click on this line, you'll notice I have my y, x1, and x2. Okay, you guys could enter your equations here and any parameters that you need. Alright, I'm going to be utilizing the spline tool just for this example. But with the spline tool, basically what I'm going to do is just create some lines that we can go ahead and revolve about this axis. So I'll grab my spline tool, place a point, and then what I'm going to do is I can go ahead and finish this shape and then revolve this about this axis. So to get this revolved, I'm going to move to the Features toolbar and click on my revolved boss base. Now what that will ask for is an axis of revolution, the degrees in which I'm revolving it about, and what selected contour I want to revolve. So I'll click on my axis of revolution, and I'm going to click directly on my axis. Now you'll notice automatically it revolves this shape. Okay. What I can then do is back down my degrees depending on how many degrees I want to revolve this. In your particular case, you're going to be going 360, I believe, so we'll close this to 360, and I will check this off. If for some reason this didn't work, double check that your thin feature is not checked. Alright, that would cause an error. And if that still doesn't work, you can click in your selected contours and make sure you have your selected area in which you want to revolve highlighted. So I'll check that off, and there's my shape. So this is the shape that I just spun about that axis. Almost looks like a top. To take this a step further, you guys would have to go ahead and calculate the volume of this shape. Okay? What I can do directly in this software is I can go ahead and click on my Evaluate tab, click on Mass Properties, which will calculate the mass properties of this model, and it directly outputs my volume to me. Okay? So what you're going to be doing is looking at how you're calculating the volume of your object. You'll see my origin showing here with my axes. Alright? In this program, it's pretty neat. We could input a material and get an accurate mass calculation. I know you guys aren't going to be looking at that, but I could edit my material, and let's say I was creating this out of a aluminum alloy, and I was looking at like a 1060 alloy, which is a very common alloy. I could actually tell you that if I were to create this out of aluminum, it would weigh 1.73 pounds. Alright, so my volume stays the same, however my weight is dependent upon my material. Okay? Now, let's go ahead and look at my revolve and my sketch over here. You'll notice my revolve is driven off my sketch. I'm going to click on my revolve and hit delete key in the upper right hand corner. Make sure it's not the traditional backspace but the delete key, and I'll delete my revolve. I'm going to hit spacebar and hit normal 2 to square up to that object, and I want to show you one thing a little different. So I'm going to edit my sketch, and I'm going to delete this line. Let's say for whatever reason you guys are creating something that looks like a traditional pint glass, like a a glass that you may be getting water out of, or whatever it might be. If we were to take what would look like a traditional pint glass, I'm going to draw half of my pint glass, and if I were to revolve that, uncheck my thin feature, change my axis of revolution to this one, you would have your traditional pint glass. Okay? We could once again calculate the volume of that. If I back up and let's say sketch something that looks like this to make this look like an actual pint glass where we have glass sides but it's open in the center, what I could now do is say features revolve. My axis of revolution is this line. My selected contours become this, and I uncheck thin feature, and you would have a pint glass. Okay? If we go ahead and calculate the volume of this, so evaluate mass properties, you'll see the volume is 2.15 cubic inches. Okay? That is the volume of the actual model, the solid material. If I'm looking for the volume of this inside, or how much volume this pint glass could hold, what I would recommend to do to get that is I would delete my revolve. So once again, on the right hand side of the keyboard, hit the delete key, not the backspace but the delete. And I'm going to square up to my sketch, so spacebar normal 2. Let's just go spacebar front. There we go. And what I'm going to do is features revolve, but instead of revolving this selected contour, I'm actually going to revolve this contour, which is the empty space. So that's the empty space of my pint glass, and when I spin that, you'll notice that that is the exact volume within my pint glass. So I'll check that off, and now if I go to evaluate mass properties, it tells me the volume in which that pint glass could hold, the 9.74 cubic inches. Okay? If for whatever reason you need this in metric as opposed to the standard English or standard American, we could hit options over here, options, document properties, units, and we could change to any one of our systems. So I'll just change to millimeters, grams, and seconds, hit OK, and now when I go into my mass properties, you'll notice my volume is done in cubic millimeters. So whatever you're calculating this in, there is a variety of standardizations that we can look at for measurement systems. As I said earlier, you guys will be sketching about an equation-driven curve. Okay, so you'll be able to draw your curve based on the equation that you derive and enter this formula. The revolving concept will still be the same, the volume concept will still be the same, and that should allow you to go ahead and verify your results. What I would recommend is, once you have your results, let's say this is my shape that I needed to find the volume of. Okay? What I would recommend is we're going to create a simple report in OpenOffice. So OpenOffice is on Microsoft Word in this room. So we'll click on OpenOffice, and for this report I'll use a text document, and what I can actually do within this text document is now I can bounce between my Solidworks and my OpenOffice, is I can take screenshots of my revolved feature. If you hit spacebar isometric, that'll give you a nice perspective view of it. And we have a snipping tool on this computer. If you can't find it, you could simply type in snip. It'll pop up the snipping tool, which will allow you to take screenshots of it by simply dragging your cursor around that. Now, you'll see that goes ahead and produces a screenshot. I could copy this and insert this by edit, paste, and insert a screenshot, so that if you were to generate a nice report here, you could have a nice report generated. You can also come over back to SolidWorks, evaluate mass properties, and copy your volume if required. So I can right click, copy, come over here, paste, and get a nice report generated. generated. Hope this helps in your ventures. I hope you guys enjoy your experience in SolidWorks, and if you have any questions, please feel free to ask Mr. Kozlowski or Mrs. Cunningham. Good luck and enjoy.